Welcome back to Alchemist Camp. This is where we learn Elixir by building things. So last time we were building a minimal to-do list. It's all command line driven and reads from .csv files. And we got about a little more than halfway through it, I hope. So right now it lets you read to-dos, it lets you delete to-dos, and we can only load a CSV at the very beginning of running the program. So the things we need to implement are adding to-dos, saving CSVs, and loading at any time, and then also creating a new format for a to-do. Like if we just want to create a totally new CSV and define the headers for the titles and all that stuff. So I would say the simplest thing to do first is load. So actually let's go full screen here. Just make a new command for load CSV, and we're not going to pass this one data. The reason we're not going to pass it data is because it's already got the data in the CSV. We're going to wipe out the data we've already got. QR, you know what? This is out of place. QRS. Okay, that's good. So we get more and more functions. It's going to be good to have things alphabetically sorted. All right. Define using that user snippet that I showed you last time, load CSV, and we're not going to have any arguments because we're not taking any data, and get rid of that. And you know what, we can actually just take this from start and use the exact same code because that's already loading a CSV for us, and then in start we will just call that CSV. Okay, next task is to add a to-do. So we'll add another command in here. Add to-do. And we are going to pass it data because after we're done adding it, it's going to add itself to the data and pass the updated data back to everybody. So add to-do data. All right, let's do a little bit of planning here. So first thing we've got to do is get the name of the to-do. Then we're going to have to get all the titles, which we can get from the data. And then we're like, this would be like urgency or priority, things like that, the column headers. The next thing we want to do is get the field values from the user. And then after that, we're going to want to create the to-do, merge into data. And once we're done with that, we're going to get command with the new data. So we'll call it new data. Okay, so getting the name is pretty straightforward. We'll just make a helper function to do that. Call it get item name, and we'll pass it the data, and make our function down here. And while we're doing it, we're going to move delete up because D is before G. All right. Get item name, we're passing data, so we're just going to do this pretty much the way we've been doing all of them. So we'll use io.get, enter the name of the new to-do, and give them a space, have them entered on the same line, strip out the carriage return from their response, and let's see, we need to see if that to-do name already exists. Like if they already have a to-do to take out the trash, you can't create another one called the same thing. Since all our data is stored in one big map, the way we'll do that is check to see if the map has the key of the name that they just entered. And if it does have the key, say to do with that name already exists. And then we'll just keep asking until they get it. And if it doesn't exist, then name, we'll just return the name that we got. Okay, let's check this out in IEX and see if it's working. So I hit Control tilde since I use Visual Studio Code. IEX.bat. Right, compile to do minimal underscore to do.ex and undefined new data. Oh yeah, okay. So we'll just comment out that whole line. That's fine. Okay, compiled now, and I'm going to import just so that I can run any of the functions from minimal to do without typing in minimal to do dot. All right, and let's test our add to do. Isn't going to work because we haven't done all that, but we can call it and use the get item name. So add to do. Actually, we'll just load it in CSV. Just run the whole thing. Start. Okay, still loads. Very good. To do.csv. It loaded them. All right, we'll try to add a to do. Enter the name of the to do. The name is clean desk. Clean desk. Okay, that worked. So the next thing after we've gotten the name is get titles. Get titles, I think we can also make a helper function to do. To make this a little bit clearer, I'm going to set a data function. We're just going to look at the data that we already have. Data equals read to do.csv. That's not the data. Data equals read CSV. Let's see. I've got to parse that. That should work. Oh, it was trying to parse just the string todo.csv instead of all the data that came from it. Okay, so here's our data. So how do we get the field names? Well, remember map.keys of data will get you the names of the to-dos to be done. So we can just take the first of those, which we need to do with HD. So that's C doctor. All right, good. And if we look at what is inside, or what the value of that key in the data is, we get the information. And this is another map. We can just pass that to map.keys. Yeah, that's all the fields. So get fields is going to be a really simple function. Get fields from the data, and just data hd map.keys data passed into map.keys. Okay, and the next thing we need is, since this is set up with an arbitrary number of fields, we'll have to just loop over them. Well, not loop, but we'll just have to enumerate over them to ask the user for each one. So we need a helper function to get one field from a user first. We'll just call that field from user. Put it up here. Field from user. The name of the field. Field is going to be equal to io.gets, and the name that we got in. All right, we'll strip that as usual. So this will just prompt the user with the name of the field. It'll just be like priority, and they type in what the priority of it is. And in the case that, actually, no matter what the field is, so just use a wildcard match, we will return the name of the field, which would be like priority, and then the field data, which would be like 1. This is going to look very similar to the structure we saw that we built with enum.zip last time. So we'll just have a whole bunch of tuples that are just name, value, because we can use enum.into to build a map out of that really easily. Okay, now the next step is going to be we want to make a new to-do out of the fields, and I'm trying to think if we need another helper function. I think we might be okay. All right, so get titles, we already made that. That's titles are going to be get fields from the data, and the fields themselves are going to be enum.map. We're going to map over all the titles, and then we're going to supply map a function. Oh, map, if you haven't used it before, just it just executes a function on every single element in an enumerable collection. So for example, I'll put one down in IEX here. For example, you could have a list of, say, some numbers here, like 1, 2, 3, 4, 5, and then we could map over them. And give it a function that, say, squares the number. And map returns a list the same length as the one that we gave it, and it's executed this anonymous function we gave it on every single element of the list. So it transforms a list into another list, which has all been transformed by the same function. So for each of these titles, we are going to run a function on it that, right, gotta have the, yeah, we'll call it field, and we'll get the field from the user for that field. So for each title that we go through, it will ask the user for the value of that field. And then in our field from user that we just created here, it's going to return the title of the field and then whatever value the user gave it. Okay, then we're going to make the new to-do itself. So new to-do is just going to be the name. Name will be the key, and then we'll use the same enum into that we did yesterday, fields, and we're just going to put it into a blank map. So this fields, this enum, sorry, the fields that we're passing to the enum into is a list of tuples, and it'll just combine those tuples into key value pairs, which go into the map. All right, then we're going to say new to-do. We'll quote the to-do that we just made, added. And the new data is just map.merge the existing data and this one new to-do that we created. Done that, done that, done that. All right, let's give it a try. Let's see, does not exist. Ah, yes. You used to be able, in Elixir, you used to be able to just, no, that's not right. Name, oh, I didn't set the name here. Name equals that, okay. I was going to say in Elixir, you used to be able to just call functions with no arguments without putting the parentheses in, but now you can't do that. You can only do it in a situation like here where there's an argument and it's clear that getFields isn't just a variable. Let's give this a try. Still, oh, it didn't save it, so it's exactly the same as it was. All right, so now it's loading and we will start. Name of CSV to load, todo.csv. I'm going to add a to-do. The name of the new to-do is clean desk, and the date, December 13. Notes, no notes. Priority 5, urgency 3. Read the to-dos. All right, we've got add a to-do working. Next step is saving a CSV, and this is going to be quite a bit more difficult. And that's because we've got to convert the huge map that we store all the data in into a CSV and then write it out to a file. So it's going to be a bit of data processing. Save CSV. Definitely going to pass that data since it's all the whole thing it's doing is reading the data. So QRS, put it there. Save CSV data, and all right, so the first thing we need to do is get all the fields. That's pretty easy because we've got a function to do that. The fields equal get fields data. That's not complete though, because if we look in the CSV itself, the first thing is item, but we don't use the item field in our data representation. The reason we don't is because we use each of the items' names as the keys that contain the rest of their information. So we're going to have to add item onto the fields. Show you an easy way to do that. So get, actually, do we have the data still? Yeah, we do still have the data. So we get fields on this data. Oh, that's not compiled. Oh, I think I just need to re-import it. Minimal to do. There we go. Get fields on the data. So this is a list. And as you might recall from last time, you can build up lists like this. It's a list of 2 things. This is a list of 3 things, and so on. So it's really easy to add something to the front of a list. The way you do that is you just use the same syntax. So we can just add the word item like this to our other fields, and then we've got them all. So we're going to do exactly that. Headers equals item prepended to the front of the fields. And you know, we can just make this one line. So call this get fields data. Okay. Then our items, that's something that's also very easy to do with the structure we picked. It's just the keys of our data map. Item rows just means all the rows except for the headers. Items were the keys from the map, and we can get the data from those items by looking at the values of the same map. So let's look at our data map again. So you can see doctor is a key, take out trash is a key. If we look at map if we look at map.values, well, we'll do it one step at a time. So if we look at, if we do a lookup on the map with cDoctor as key, if we do that, then we can see all the value associated with, or all the information associated with the doctor. Inside of this, we have a whole bunch of key value pairs. The keys are the names of the fields, and the values are the information. So we want to get the information out. The way we can do that is by using map.values. And here we go, December 5, might be nothing, 1, 3, so that's exactly what we're going to do here. And we want to do that not just for cDoctor, but also for take out trash, for whatever to-dos there are. So we'll use enum.map to go over all of the items in a list, and then return a list with the information related to the items. And we want the item in the list as well. So we'll do item followed by map.values data on the item. So this way we should see take out trash and then the information associated with it. So we get it all in one row. And then after we have the item rows, we want to not just have those rows, but we also want the header row. So in total, our rows are first the headers and then the item rows. And each of these rows is something that looks like this, plus the item name on it. And so you can see it's a list of strings, but a CSV isn't structured that way. It's just a just a binary file. So instead of a list of strings, we want to convert each of these rows, each of the lists, which each row is, into a string, and we join the elements with a comma, since it's a comma separated value data structure. So row strings equals enum.map rows, and then function x enum.join x and comma. And in this case, so above here, this anonymous function, this item is descriptive and it's clear, and it makes the function better to have that much information. This one, we really just want that particular row. We just want that one. So we can use a terser syntax. There's no reason not to. So this is an anonymous function, and that is the first argument. And there's only one argument in this case. Okay, so that will map over all the rows and join each of those rows with commas. Then we have a whole bunch of row strings. This is a list itself, because remember, maps convert lists into other lists, and each of these items in this list is a string that represents a whole row. We need to join the rows with new lines. And then after that, we'll have to open up the file. You know what? This is already pretty big for a function, so we're going to call this prepare CSV. Then we'll make a separate function, save CSV. And this one will handle the IO. File name is io.gets name of .csv to save. string.trim, and then the file data is just going to be what we get from prepare CSV. And then we want to handle a few cases. So using file.write, which is almost the same syntax as file.read, except you also have to pass it data as well as the file name. So file data, and this data is just a huge string or binary of all the contents of the CSV. If we were writing a huge file, then we'd want to have something that was streamed, but in this case we'll just do it all in one shot. Okay, so file write, just like file read, can return an OK, or it can return an error with a reason. So if it's OK, we'll say CSV saved, and if we have an error and a reason, we will put could not save file, and then give the name of the file. And then we'll say we'll get the error. What was that error? Oh, here it is. File dot format, this Erlang function, file dot format error reason, and I'll give it a new line. I think we'll quote the reason. That looks a little bit better. All right. And is there anything else to do? Yes, if it fails, we want to try again. Actually, no, we don't, because there's a data problem and the user's probably not going to be able to do anything about that. So if it fails, we'll just git command. All right, let's give it a try. Recompile, and missing a closing parenthesis. 1, 2, 3. Yep, we are. And no errors. All right, good. So the name is todo.csv. We're going to add it. We're going to read the to-dos. We're going to add one. Clean desk. Date added, December 19th. Notes, no notes. Priority 3, urgency 5. Okay, read the to-dos. So we have a new CSV. Let's see if we can save it. Name the CSV to save. We'll call it desk.csv. It says it's saved. Oh, all right. So we've written a CSV. Yay. With that little victory under our belt, let's improve this a little bit. So we've got, after we save it, it just ends the program. I think we want to keep on going. So we'll do get command data, so that now we save and then we can keep on using the program. There's one other thing that we gotta deal with, and that is if we're starting the program, we have to load a CSV. Okay, let's run this. So if we don't have a CSV to load, it just never lets us do anything. That means the only way to use this program is if you create a CSV yourself with the title with the column headers that you want, then you load it, and then after that you can write to-dos to it. Well, you have to have one to-do, so you actually have to have one to-do at the beginning, and then you can write to it, and then you can delete to-dos, and you can save it and all that stuff. So let's make a way to make a new CSV. we'll go up to start. And instead of just load CSV, we'll give the user an option. So we get input as we usually do. io.get. Would you like to create a new .csv? And we'll just have them write yes or no. Actually, we'll only see if they write yes. If they type anything other than a Y, that'll be a no. And we want to trim that string. And we want to downcase it in case they type a capital yes. String.trim. And if the input is yes, then we'll create initial to do. And after we're done with that, we will pipeline what that returns into get command. The reason for that is we're going to have our initial to do basically give us our initial set of data, which just contains that one to do, and that becomes the data that gets passed to get command and all over the rest of the program. And otherwise, we'll load a CSV. Okay, so now we got to make this create initial to do function. Okay, so we'll make that. Create initial to do, and we're not passing it anything because it's the very first thing. We have no data. And let's think about what we need. We need titles, so we'll have to create the headers, and we need a name of the to do, and then we need all the fields filled in, kind of like we do when we create any to do. And then we have to make the initial data structure from that to do. So let's actually, before we do this, let's make a create headers function. Create headers, and that also has no data. So io.puts, what data should each to do have? Going to be a long line, that's why I didn't do another io.puts. Enter field names one by one and an empty line when you're done. Right, and then we're gonna have to build this up recursively. So I'm gonna call a helper function, actually kind of the real function, called create header, and I'm going to pass it an empty list. This create header is going to contain all of the items that are all of the column headers that we've entered so far. So create header, and this has a list of headers. The first time you call it is from this create headers. Then each other time, like after the first one, it's just calling itself and passing more and more and more headers. So this will have a case, gets, add field. We'll just prompt them to add the field, and they'll write it right next to it, like we were doing with supplying the information to go in the fields when we make a single new to do. String.trim do. So based on the field names we're getting from the user, if it's empty, which means they just hit enter for a new line, then we're done. That means they've entered all the fields they want to enter, so we'll return the headers. And if it's already got some, or if they've input something, we've got a header, and we're going to pass that header right into this same function, because you're going to keep going until they enter nothing. So create header, and we want to call it with the header that we just got. and all the headers we already had. Remember, this is a list, so this syntax will create another list that has everything headers had, and it's got header at the front of it. And we'll end the case statement. This should work. Let's check it out in IEX. So I guess I just quit IEX there. All right, so compile minimal todo.ex, import minimal todo, and I think we can just run create header by itself. We can't because it needs input. We can run create headers. All right, so what data should each todo have? Enter field names one by one and an empty line when you're done. All right, so todo should have priority. Make it capital. And it should have urgency. And it should have maybe just those two. Urgency, priority. Ooh, looking good. Yep, okay, so create headers is working. Then back to our initial to-do. Our titles equals create headers. And the name is going to be the name of that item. Let's make another helper function to do this. Get item name. And the data we're passing it is just an empty map because we have no data yet. We got to get all the fields, and we've already got a field from user function. We're just going to use that again as well. Okay, so name is get item name, which we've already made, and then fields is enum.map, and this is very similar to the code we had in our add to do function. Field from user, field end. Okay, and do we really gain much? You know what? I think we're going to make this the terse syntax as well. Go. And after we've made the fields, we'll tell the user that we've succeeded. New to do name added. Actually, we're gonna have quotes there. All right. Then the final thing is we've got to pass the data that we've created, and the data is right now it's just this one to do, so it is name of that to do is the key, and then the value is enum.into fields and into an empty map, because right now the fields are just tuples, basically key value pairs that are destructured into tuples. So that's exactly what enum into is for. Is this correct? No, that's not correct. It's going to be a brace because it's an object, it's a map. All right, let's give that a shot. Create headers. That does look good. Okay, so reload. Titles is unused. Where are we? Line 41. Oh, that's just a warning. Yeah, because we're not actually gonna run create initial to do yet. Wait. Actually, all this should be in create initial to do. Yeah. It's basically the same deal since this function is a helper for this, but we want to have access to titles. Yeah, Okay. Now we'll save that. Give it a try. And we get a warning. Initial to do did not exist, is being expanded into initial to do. This is what I was talking about with the you can't do the Ruby style syntax. Easily fixed though. Okay, we got one more undefined function name on 38 because looks like I just got an extra line there. All right, should be good now, and it is. And we'll do minimal to do dot create. Actually, we'll create the whole initial to do. That should all be working. Initial to do. Okay, what fields should we have? We're just going to have priority. Yeah, urgency. Okay, that's it. Added the name of the new to do. Clean bathroom. It's not really urgent, but it is a priority. Excellent. Okay. Now let's try running the entire thing. Create a new CSV? Yes, I would. This time we're going to have importance as a field name, and we'll have due date, and we'll have notes. That's it. The name of this to do is buy pizza. Notes. Due date yesterday. Importance 10. Read the to do's. Okay, I'll add another to do. Organize bookshelf. Due date someday. Importance 4. No notes. And we'll create another one. Learn Elixir. Due date December 19th. Importance 100. Notes. It's very fun. All right, read the to do's. Let's see if we save it. CSV. My list.csv. My list.csv. That's looking pretty good. Let's reveal this in the Explorer, and let's open it with OpenOffice. And that's right. And there we go. We have made a CSV. So now this reads to-dos, it adds them, it deletes them. You can load a CSV, you can save a CSV, you can create a new CSV. The fields themselves in the CSVs are arbitrary. You can handle any number of fields in your to-dos you want. This is a pretty good spot to wrap up here. There are a lot of things that could be done to improve this to-do program. I mean, this is literally 165 lines that was written with very little preparation and just thrown together pretty quickly, and without using the normal utilities or, you know, getting somebody else's CSV parser or anything like that. Now, obviously, it's good for a learning experience to see how the Elixir file and IO utilities work and do some data manipulation to make your own CSV parser, but it's not the ideal way. The other thing is that the order of the to-dos aren't preserved here. You may have noticed that the order they are in the file when we load it in isn't the same as the order that we have them when we're printing them out. The reason for that is maps don't preserve order. So if we wanted to change that, and we still weren't using some sort of in-memory data store, we would probably use tuples. And if we were to make this more robust, then we'd use some utilities that are built into Erlang VM that could store the data for us, or we'd just use a database. But after 2 long sessions with the to-do list, I think it's time to move on. Tonight's challenge is a math challenge, sort of. So there are these numbers, or there's a sequence of numbers called Fibonacci numbers, or the Fibonacci sequence, and it goes like this: 1, 1, 2, 3, 5, 8. And you can see each number is the last 2 numbers added together. So 2 plus 3 is 5. And you can see 8 plus 13 is 21. And the next number would be 13 plus 21, and so on. So your challenge is to write a function to find the 45th Fibonacci number. It's going to be a really big number. So if the end gets rounded off or something, don't worry about that. Just try to get about to what that number is. And then part 2 is look at the docs for date time and figure out how to time your function. So you'll start a timer at some point, or you'll at least check what time it is. You'll run your function, and then you'll see how much time has passed. And then we'll look at that and see maybe what you can do to make the function run faster in the solution video. And until then, happy coding.